Good morning, everybody. How are you all? Today we are going to solve an ordinary differential equation. So I'll share my computer screen with you. Says a large corporation starts at time t is equal to 0 to invest part of its receipt at a rate of $P per year in a fund for future corporate expansion. Assume that the fund earns R% per year compounded continuously. So the rate of the growth of the amount A in the fund is given by dA by dt is equal to RA plus P, where A is equal to 0 when T is equal to 0. Part A, solve this differential equation for A as a function of T. Part B, find A when P is equal to 275,000 and rate is equal to 8%, T is equal to 10 years. So we'll first solve the equation. So solution. Okay. So we will separate the variables. So we will do dA divided by RA plus P on both sides. RA plus P, R times A plus P is equal to, we multiply by dt on both sides. And then we will integrate. So integrate dA divided by RA plus P is equal to integration of dt, or 1 over R ln RA plus P is equal to T plus C1. C1 is integration constant. Integration constant. Okay. So if we multiply both sides by R, we get ln of RA plus P is equal to RT plus C2, where C2 is equal to R times C1 is constant because the rate is constant. R is constant also. And C1 is an integration constant, as we discussed before. Now we take, use the definition of natural logarithm, because ln RA plus P, it is to the base E. So using the definition of natural logarithm, we will get RA plus P is equal to exponent RT plus C2, okay, which can be written as E natural number raised to the power of RT multiplied by natural number raised to the power of C2. Understand E to the power of C2, C2 being a constant. So natural number raised to the power of C2, which is a constant, is a constant. And so this can be written as C3. For E to the power of C2, we write another constant C3 is equal to C3 times E to the power of. Okay, so we have RA plus P is equal to C3 E to the power of RT. Okay, from which we solve for A. So first we will subtract P on both sides. We will get RA is equal to C3 E to the power of RT minus P, right? And then I'll create some space for myself. So we will divide by R on both sides to get A is equal to C3 multiplied by E to the power of RT minus P divided by, this is A, right? Divided by R. Okay. Or A, or we can write A is equal to C3 by R e to the power of RT minus P over R. Okay. Now, now C3 by R is constant because C3 itself is a constant and R rate is a constant. So we can write A is equal to C e to the power of RT minus P over R. Okay, this is P over R. Also, we have been told A is equal to 0 when T is equal to 0. So let's create some space for us. Okay, so now it is given A is equal to 0 when T is equal to 0. So if we use that information, we get 0 is equal to C e to the power of 0 minus P over R. Now that leads to 0 equal to C times e to the power of 0. Any number raised to the power of 0 is 1. So it is C minus P over R. Or C itself is equal to P over R. Okay. So the equation for A is then for C I write P over R e to the power of RT minus P over R. Or if I take P over R as the common factor outside the parenthesis, I am left with this equation. Okay. So this is my solution for A in terms of P and R when the money grows compound. Okay, so this is part A. Now we have to focus on part B. Okay, so let's see if I can create some space this way. So part B. So that was part A. Now part B. Part B, we have been given P is equal to 275,000. Okay. R is equal to 8%. We always convert that to a decimal, 0.08, and T is equal to 10 years. So let's move this a little bit. So that means A in 10 years is equal to P over R. P is 275,000. R is 0.08. Okay. R is 0.08 multiplied by T is 10 minus 1. Okay. So if we use our calculator, we will find the amount in 10 years is equal to, we will use the calculator. First, we will do E, that means second button, and then ln button gives me E, and the exponent of E is 0.8. Okay, that answer is 2.2255. From there, we subtract 1 minus 1 and then multiply that by 275,000 and then divide it by 0.08. And we get the answer as 4,212,796.94. Okay, so that's the answer for part B. When you invest 275,000 and that could compounded annually at the rate of 8% for 10 years. So I will stop here today. If you have any question, comment, write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a hearty thumbs up. I really appreciate that. And if you like this video, please let your friends know about it so that you and your friends can subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll see you next time when I come back with another interesting problem, interesting solution. Take care. Have a nice day. See you.